Hey students, welcome back as we discuss cloud versus physical storage. So if you're not familiar with the concepts here, cloud of course is stuff that's stored up in the computing cloud, whereas physical storage in our context, we're not talking about things like paper, we're talking about things such as your local storage, such as your hard drive or flash drive. So before we really kind of sink our teeth into this lesson, let's first talk about the storage of data. Now, computer data storage is a technology consisting of computer components and recording media that are used to retain data. Now, computers use two forms of storage, primary and secondary. Primary storage is considered to be super fast in comparison to secondary, but it's volatile, which means that like if you shut the power off from your computer, anything that was stored in that primary storage is gone, right? And it's often just called memory is the name that we often associate with. We usually don't call it storage, we usually call it memory. Now, secondary storage is slower by comparison to that of primary. There are some things where the gap is closing to make secondary storage a lot faster, but primary storage is still largely considered, for most part, going to be your volatile memory. Now, with secondary storage, one of the huge advantages of it, even though it's slower, is that the data is retained within it. All right, it's not lost when you pull the power plug out. Therefore, it's sometimes known as external storage because sometimes you can do things like flash drives or you can plug in an external hard drive. And so you can plug those secondary storages into your computer and then you can walk away with them. Now we're going to spend this lesson kind of focusing on secondary storage because believe it or not, even the cloud can kind of function as a form of secondary storage, but also a little bit as a backup. So when we start talking about forms of storage, in modern computers, you pretty much have two primary forms of storing information, which is either a hard disk drive, HDD, or a solid state drive, SSD. These are your primary forms of secondary storage. You'll have other forms out there such as flash drives, DVDs, Blu-rays. I've already mentioned like the cloud because you can store stuff out there. You can use different kind of cloud apps like Google Drive and OneDrive. Now, storage mediums, which when I say storage mediums, I'm referring to traditional things like hard drives, solid state drives, even flash drives. They're often formatted to a file system, such as NTFS or FAT32. You don't need to know what they'll stand, just know that those are the two formats that are often used for formatting, NTFS and FAT32. What this does by adding a file format system is it allows the computer to organize the data then into files and directories, while also providing metadata, which are things such as who owns the file, what access permissions you have, like can you just read the information on it, can you edit it, can you delete it, those sorts of things. All right, our first one is hard disk drives. So this is our first form of storage that we're going to take a look at. Now, a hard disk drive is a mechanical storage device that uses magnetic storage to store and retrieve digital information using one or more rapidly rotating disks coated with magnetic material. Now, I'm not going to give you a picture of a hard drive right now because I'm going to have you actually kind of look that up when we do our lab, and you have to try and identify that based upon the component shown. So I'm not going to give that to you right now because I want you to be able to do a little bit of self-discovery. Now, with the hard disk drive, the metal plates, the platters, are paired with magnetic heads, which are usually arranged on a moving actuator arm, which read and write data to the platter surfaces. Now, data is accessed in what's known as random access manner, which means that individual blocks of data can be stored and retrieved in any order and not sequentially. So rather than everything being ordered front to back, which would actually kind of take longer, like when you delete out a file, let's say out of your computer, it opens up that space where that chunk was, and because now that space is the computer is not just going to go right to the end and keep going to the end, keep going to the end. It says, hey, there's a free spot here. Let me fill that with some data. So that's why in a traditional hard drive, that information can get scattered around quite quickly because the computer wants to optimize where the information is stored on that hard drive. Now, capacity with hard drives is specified in unit prefixes corresponding to powers of 1,000. So a 1 terabyte drive has a capacity of 1,000 gigabytes, where 1 gigabyte is 1 billion bytes. Kind of a little caveat with that is that when we traditionally talk about things such as storage like terabytes and stuff like that, a lot of times things are powers of 2. So when we traditionally talk about it, it would be instead of 1,000, it should be like 1,024 bytes or megabytes or gigabytes or whatever. But this has to go back to a marketing thing where they say, hey, it's a 1 terabyte hard drive, but you're actually not getting a full 1 terabyte because if it was a full 1 terabyte, be 1,024 gigabytes. But it's a part of a marketing ploy if you want to really kind of know the reason why. Now, typically some of the HDD's capacity is unavailable to the user because it's used by the file system or the computer operating system. So if you ever like get a brand new computer, like, oh yeah, this thing's got a 2 terabyte hard drive, and you open it up and it says 1.81 gigabytes available. Even though like the only thing installed, it's like it might say, okay, you have 1.81 gigabyte total, for example. Where did the other gigs go? Well, first off, some of that comes back to this, all right, that some that's been rounded off for marketing purposes. So if you ever look at a brand new computer, like, where did all my space go? Well, some of it is for that. And then some of that hard drive space is used when you first turn on your computer and you set it up because it has to store the operating system and stuff like that. Now, solid state drives are kind of like the up and coming cousin or brother, sister, whatever you want to think, to hard drives. These are a storage device that instead of using a traditional mechanical platter, are going to use integrated circuit assemblies as memory in order to store data. Now, because there's no moving parts inside of them, there's no spinning platter, there's no actuator arm, nothing like that, no mechanical parts. They're typically much more resistant to things like physical shock. So if you drop an SSD, it's probably going to be fine. You drop a traditional hard drive, you might want to be careful with that. SSDs also tend to run less silently because they don't have moving parts, so they're not going to make you noise. And they also have quicker access time and lower latency because, again, there's no moving parts for it to have to try and search for data. It's all just a series of circuits. Now, SSDs can use traditional hard drive interfaces and form factors. So what that means is like a traditional hard drive will plug in with, let's say, for example, a SATA cable or maybe do a USB. SSD can do the same thing. Form factor, a traditional hard drive is either a 2.5 inch for a laptop or a 3.5 inch for a desktop. SSDs are pretty much almost all 2.5, but they can fit in the 3.5 form factor with a simple adaptation. Additionally, SSDs are going to follow the same storage capacity scheme that you have in a traditional hard drive. So a 1 terabyte SSD is still going to be 1,000 gigabytes. Now, the thing about SSDs, even though they're so superior in things like speed and read-write, they're not really meant for long-term storage of data. All right, if you try to store information long-term, you're going to run into a little problem with SSDs. There's a problem that they're working on solving, but because they're based around NAND memory, they don't tend to retain the information because pretty much what they do is they leak the charge, the capacitor charge inside the circuitry, kind of leaks out, and when it leaks, it starts losing the information that it had. All right, we also need to talk about flash drives before we kind of jump over to the other side of things, because flash drives are a storage device that use flash memory with an integrated USB device. You can't not know what a USB drive is these days. There's multiple names that have been used for USB drives, whether it's a flash drive, thumb drive, I've heard pen drive. These are all different names for the same thing. Now, USB drives are often used for storage, data backup, and transfer of computer files. They're very versatile. You plug them in, you dump the information on, you unplug it, and off you go to the next spot. Now, they are smaller and faster and have significantly much more capacity in comparison to a lot of other devices of their size. And they're much more durable because they don't have any moving parts. Just like the SSD, they don't have any moving parts, but you can get like 1 terabyte flash drives now that are crazy good. The only thing they're really limited on would be like the USB port. How fast is that USB port that they're connecting to? All right, now we've finally reached the other side of the coin, which is that of cloud storage. We talked all about all the physical side of things, which is things you can do on the local side of your computer. Let's look at things on the cloud side. Now, a model of computer data storage in which data is stored in logical pools is what we tend to refer to as the cloud. And this is done across multiple servers, often in multiple locations, because that way if one location goes down, they can just hop you right over to the next location and you'll never even really kind of know that you lost connection. And the physical environment of those servers where your data is hosted is typically owned and managed by a hosting company, whether that's like Dropbox or Google or Microsoft, it doesn't matter. Now, people and organizations tend to buy or lease storage capacity from the providers in order to store user, organization, or application data. Now, cloud storage is based around what's known as a virtualized interface, allowing for offsite access of the data. And when I say it's virtualized, it means that pretty much you're not actually physically interacting with the server. I'm not walking up to a server in California every time to go access like my Google Drive. I'm not going to a server, to go and access my OneDrive. I just sit down on my normal computer, I open up a web browser, or if it's some kind of application, and I access the files that way. So it's really nice because you don't actually have to set foot on the same location as those files. And the same thing goes with, like, if you think about like Google Drive or OneDrive, I can log into those files at school, work on them there, and then I'm like, oh, I need to finish them. I can go home, log into them there, and it's the exact same file. And these are the things that really kind of play into the advantages of cloud storage over physical storage. So there are some significant strengths to it. One of those is that you tend to only have to pay for the storage as needed. Yes, there are some free storage options out there, like for example, Google Drive and OneDrive you can sign up and get so much free storage, but eventually you're going to have to pay for it if you need more. So therefore, you only tend to pay for what you need. So if you end up needing more, you have to pay for it. But if you don't need it, hey, no sweat about it. There's also the ease of scalability, and this kind of relates also with that size of storage needed. So let's say I have a product launch, and I need to retain a ton of data right off the bat. Like gamers, would understand this one probably most. When video game launches, they need a lot of capacity to be able to handle the quick influx of players. So you want to be able to scale your servers up to handle this very large volume of people coming in. And then after like maybe the first few days, the player population kind of stabilizes and tapers off a little bit, where you don't need quite as much, so you can actually scale that right back down. Whereas if you were to go and buy a bunch of new servers, all of a sudden you're like, hey, I need to get like 50 new servers because my 50 that I have are stressing out because it's the launch day. And then after the launch day, you're like, well, I only needed the original 50 I started with, and now I have 50 more just sitting around acting empty. So the scalability really helps with that. Also, cloud storage has a high fault tolerance and redundancy of data. Maintenance and upgrade costs are also offloaded onto the service provider. So that means that your data is not only secure with the fault tolerance and the redundancy, because if a server goes down someplace, you don't have to worry about it, because again, the maintenance and the upgrade are responsibility of the service provider. It's not like if your personal computer goes up, well, you got to figure out how to replace it, see if it's salvageable, if your data is okay. You don't have to worry about that with the cloud. Now, there are some disadvantages, of course, with anything with the cloud. Obviously, with the cloud, because it's not just in one location, it's in several locations because they distribute out in order for redundancy. You have what's known as an increased attack surface area. Because your data is in more locations, there's more chances for somebody to kind of intercept that data or compromise it or whatever. A more legitimate concern too that often crosses people's mind is that data still going to be available if the hosting company ceases to exist? Many years ago already, it doesn't seem like that long, but many years ago, there's a company called Make Upload that had a bunch of stuff that was, people's home videos, people's family pictures, whole bunch of stuff. But they also had, unfortunately, some stuff that was considered illegal up on the site. And what happened is the FBI came in, raided their headquarters, shut the servers down. There wasn't any warning given, and people lost access to their files. So, it's a very real thing you have to be concerned about is, are my files always going to be safe? Now, performance and reliability are always going to be lower than that of locally hosted data. Think about it this way. If you are, for example, let's say a gamer, this is the easiest example I can give because it's the most real one. Anytime you try to run something on your computer, if your computer has the graphical capability and the CPU bottleneck doesn't exist, you can run a game far more powerful than if you were to try to stream that game over the web. And I know there's been some things where people have tried to make that seem like it, but no matter what you do, you're going to run into some latency issues. Whereas if it's local, the only latency issues you have are between your computer and the server that you're trying to connect to. All right, and that's going to wrap it up, folks. It's kind of a little bit longer one than the one we had last time, but it's very important for you to kind of understand those pros and cons and understand the differences between those different types of storage. So with that being said, I'm going to wrap it up and see you in the next video.